Come back. Problem 17, section 2-3. You're told that function f is this one in blue, function g is this one in green. P is f times g, q is f over g. Find derivative of p and q at 1, derivative of p and q at 6. All right. So we need to use these graphs. Now, p is product. So derivative of p, derivative of the first, second as it is, plus first as it is, derivative of the second. Using this, derivative of p at 1 will be derivative of f at 1, g at 1, f at 1, derivative of g at 1. I'm simply replacing x by 1. Now what is the derivative of f at 1? So blue is f. At 1, notice it has horizontal tangent, right? So derivative is 0. What about g at 1? At 1, g gets value 3. Okay. Anyway, it doesn't matter because it's multiplied by 0. What about value f at 1? Value f at 1 is 2. What about derivative g at 1? At 1, what's the derivative? Well, this is a line edge, right? So what's happening here? This line segment has a rise of 1 for every run of 1. 1 over 1. 1 over 1. So derivative here is constant 1. So g prime. So this is going to give me, p prime at 1 is going to give me 2. All right. What about p prime of 6? Same argument. Instead of 1, I have a 6. All right. So let me figure out derivative of f at 6. 1, 2, 3, 4, 5, 6. So I want to find the slope here. Notice this is a line segment. So this line segment looks like it has a rise of 1 for a run of 4. 4 times you have to run to get 1 rise. So the slope here is 1 over 4. All right. What about the value of g at 6? 1, 2, 3, 4, 5, 6. The value at 6 is 1, 2, 3, 4. Okay. Plus value of f at 6. Okay. That's a 4. And the derivative of g at 6. Okay. Slope of this line, rise of 3 for a run of 1. 1 run gives me 3 rise. So 3 over 1. All right. So now simplifying this. 1/4 times 4 is 1. 4 times 3 is 12. So in all it's going to be 13 for p prime. Okay. Next for q. Q is f over g. So derivative, I need denominator squared, derivative of the top, denominator as it is, minus numerator as it is, derivative of the denominator. If I substitute f prime at 1, we just saw it is 0, so that gives me 0 no matter what g is. And here f of 1 is 2, and derivative at 1 of g, that has slope 1. So negative 2 over 9. Q prime at 6, well, f prime at 6, we just saw slope was 1/4, you see, and g at 6, we just saw height was 4, minus f at 6 is 4, and g prime we just saw was 3. Okay, so that's a 1/4 times 4, 1 minus 12, negative 11 over 16. Okay, next question. Looks like there is some warning, but I don't think it's an issue. Find an equation for the tangent line of f at this point, where f is given by this. Always when they give you a point, check, make sure this point is on the curve. Plug in x equals 2. I get 8 times 5, 40, minus 4 times 5, 20. 40 minus 20 is 20, plus 6, 26. So this point is indeed on this curve. Now, your given point, we did check. To find equation of tangent line, we need point, which we are given, and slope. To find the slope, we need derivative of f. F being this function, derivative, this is a polynomial, so it's simple, straightforward. Bring the 3 down, 5 times 3, 15, reduce power, x squared, minus, bring the 2 down, 10, reduce power, x. Derivative of constant, 0. So all you have is 15x squared minus 10x. The point is at x coordinate 2. X coordinate has to be 2. Plug in x equals 2. X equals 2. So I get 15 times 4 minus 10 times 2. 60 minus 20, that is 40. So slope of the tangent line will be the derivative at 2, that's 40. To write equation of the tangent line, you use y minus y coordinate equals slope times x minus x coordinate. Simplify. Y minus 26 equals 40x minus 80. So y equals 40x minus 80 plus 26. Simplify that. 40x minus 54. So y equals 40x minus 54. All right. Next problem will continue in our next video.